Hello everyone, my name is Chase Douglas. I'm the event coordinator here at Eco Canada. So I'm going to get things started before Jenny takes things over. So starting off, we are just going to go over some housekeeping. So all participants are muted during this webinar. For any technical issues, use a question box function and select Eco Canada. The webinar will be recorded and sent to everyone within 24 hours if you registered for this webinar. And any questions can be submitted through the chat question box function. We do ask to hold all your questions to the end, and we'll go through them when we come to that part. So traditional land acknowledgement. Eco Canada and myself would like to recognize today and every day the land we are on. Eco Canada is committed to reconciliation, starts with acknowledging our honor and privilege to live within this Indigenous territory. Eco Canada acknowledges the traditional territories and the oral practices of the Indigenous nations. So who is Eco Canada? A little bit about us. Eco Canada is the steward of the Canadian environmental workforce from across all industries. We champion end-to-end career of environmental professional. We not only train and certify professionals, but we also help identify and address labor market gaps. Our efforts promote and drive responsible, sustainable economic growth to ensure that environmental care and best practices is a priority. So hand this over to Jenny. Jenny, take it away.
Thank you very much, Chase. Just a quick introduction. My name is Jenny Peters. I am the Director of Research here at Eco Canada, and Eco Canada is engaged in a lot of research about the environmental workforce. This particular research project was funded by the Sectoral Workforce Solutions program, funded by ESDC of the Government of Canada. And we had a couple of really important research objectives for this research study that I'm going to be talking about today. We wanted to gain a deeper understanding of what was going to be required in order to contribute to the EV batteries. And we also wanted to figure out if there were any particular opportunities for the skilled talent pool that we currently have to meet those needs. This report is available on our website for free, along with a lot of the other research that we do. Next slide, Chase. So first question, what is the electric vehicle battery supply chain? We've heard about this from time to time. The Government of Canada is putting a lot of emphasis on developing the battery supply chain. So what is it? Well, overall, a battery supply chain is the start to finish of creating a battery. So it includes the minerals and the materials that are required in order to build the battery. It's the battery processing and creation. It's the use of the battery and assembly into the EV itself. And then it's the recycling and reuse of the battery. So we've got the upstream mineral and exploration and mining sector as part of the EV battery supply chain. We've got the midstream sector, which is the actual battery material production. We've got the downstream sector, which includes the battery manufacturing and pack assembly, as well as the EV assembly. And then we've got the recycling and reuse, where hopefully we can turn those materials back into a productive product again. On the right-hand side of your screen, you can see the particular industry classifications that we looked at in this particular research study that were relevant to these very different components of the EV battery supply chain. The NAICS indicates the North American Industry Classification System, and that classification system is a joint effort of the Canadian, US and Mexican government to systematize the industries across those regions. So these industries, including support activities for mining and oil and gas extraction, architectural, engineering and related services, metal ore mining, basic chemical manufacturing, motor vehicle parts manufacturing, other electrical equipment and component manufacturing, motor vehicle manufacturing, and then remediation and other waste management services are all industries that these three countries recognize. And these are the particular industries that we focused on. So we looked at companies that were in these particular sectors. Now, there's a lot of interest in Canada as a potential global leader in the EV battery supply chain. And one of the main reasons for that is Canada is blessed with minerals and materials that would be required for EV batteries, including copper, lithium, cobalt, rare earth minerals, nickel, manganese, and graphite. If you take a look at the right-hand side of the slide, you'll see how much these minerals, the mining of these minerals has to grow globally in order for us to be able to meet the needs of the projected EV battery supply requirements. So we're expected to see a 42% increase, not a 42% increase, of 42 times growth of lithium. Cobalt mining is going to have to grow by 21 times, graphite by 25 times, nickel by 19 times. That's a lot of additional mining that's going to have to take place in Canada as well as globally as well. So the question then becomes, we've got all these minerals and we've got all of these, we've got great mining expertise that we can apply to the extraction of these minerals. The question is, are we going to be able to get those mines up and running in time for us to develop the EV battery supply? We have seen some very notable recent investments. Some of these are very large investments into Canada from a variety of different companies in the battery supply chain. Most of these investments have been in, these investments have been in Ontario and British Columbia and Quebec, my apologies. And some of these are in the billions of dollars. If you take a look at the Nexstar Energy battery cell manufacturing plant in Windsor, Ontario, that's a $5 billion investment. Volkswagen has invested $16.3 billion in another battery cell manufacturing facility. And then Northvolt, yet another in Montreal, Quebec, another 7 billion investment. So we're seeing some really substantial investments in these facilities. The question then becomes, do we have the minerals in order to be able to produce those batteries that we want to produce? And more importantly, do we have the labor? Do we have the skilled workers that are going to be needed in those facilities in order to be able to operate and produce the batteries that we want for our EVs? A few things came to the surface when we did our research. We talked to a number of different organizations, 11 different organizations in the battery supply chain space, and they indicated a few things that might be obstacles or challenges that we need to overcome in order to be able to reach our goals in the EV space. The first is, despite all of these investments, Canada has not previously had a battery materials processing sector. And so we don't have skilled workers in this space right now. There are a lot of other countries globally, China in particular, that have experienced workers, but we don't at this moment. So building that skilled labor force is going to be an important component of meeting our supply chain goals. We also have very tight timelines. We have some very ambitious goals that the federal and provincial governments have put forward for EV adoption. And the ability of Canada to supply those EVs through this battery supply chain is going to be challenged simply because we need to get those facilities up and running really quickly in order to meet these really short timeframes. And then the other factor that we are missing in the supply chain itself is we don't really have a recycling or reuse side of the supply chain at the moment. We have a few companies that are working in that space, but we don't have an integrated or well-developed sector that we can use to take those materials once they are finished with their lifespan and turn them back into productive products. The other thing that we're missing in terms of the battery supply chain is the infrastructure that is needed in order for those large manufacturing operations to go up and become working facilities. So we need access to sufficient electricity, they need road networks, and they need large industrial land tracts for these large manufacturing operations. And this infrastructure still needs to be constructed as well. So if we take a look at the state we're at right now, we're really at the starting gate of the electric vehicle battery supply chain sector. And that gives us a little bit of leeway in terms of getting the skilled workers up and running and ready to produce in this sector as well. Our research identified 6 broad categories of workers who are going to be critical to the EV battery supply chain. They include people who are in technologist and technician positions. They include a wide variety of different types of engineers, as well as computer and data scientists, supervisors, skilled trades, and laborers who are operating on the factory floors doing the manufacturing itself. Let's dig a little deeper into each of these, see where these occupations are going to be needed and which specific roles or jobs are going to be in demand for the EV battery supply chain sector. So we'll start with the technologists and technicians. We identified 3 groups of technologists and technicians that are going to be required for the EV battery supply chain sector. First, we have the electrical and electronics engineering technologists and technicians. Of course, that makes perfect sense. We're dealing with an electric vehicle. We're going to need people who have expertise in electrical and electronics. We're also going to need industrial engineering and manufacturing specialists, technologists and technicians, as well as mechanical engineering technologists and technicians. And these technologists and technicians are going to be needed basically across the entire supply chain, with the exception of the electrical and electronics engineering specialists who might not be required for the mineral exploration and mining sector, but they are going to be required for the battery material production, the cell manufacturing, the EV assembly, and the recycling and the reuse. So let's move on to the engineers that are going to be required for the EV battery supply chain. So we've identified 6 types of engineers: chemical, electrical and electronics engineers, industrial and manufacturing engineers, mechanical, metallurgical and materials engineers, and mining engineers. If we take a look at the mechanical and mining engineers, they're going to be required for the mining operations themselves, which is an important role because they're going to be the ones that are going to be designing the facilities, the mining facilities, as well as the operations of those facilities. We're also going to need chemical, electrical, electronics, industrial and manufacturing, mechanical and metallurgical and materials engineers in both the battery material production and the battery cell manufacturing sectors. In the EV assembly space, we're going to need the electrical and electronics engineers, the industrial and manufacturing, and the mechanical. And then we're going to need all of those engineers except for the mining engineers in the recycling and reuse space. For computer and data science, and we're going to dig a little bit deeper into what these people are going to be doing, they're going to be needed across the board with the exception of the mineral exploration and mining sector. So we're going to need computer engineers, software engineers, and data scientists to do a wide variety of different types of activities to make these material production facilities work, to get them up and running, to get the manufactured products out the door, and to get them recycled and reused at the end of their lifespan. Now, when we turn to the staff that are going to be on the plant floor, for example, let's start with the supervisors. These are individuals who are experienced in operating and the skilled trades that are required for these particular operations. They include supervisors in machining, metal forming, shaping, and erecting trades. Those individuals are going to be needed for the battery cell manufacturing and for the EV assembly, for actually shaping the cars themselves. The mechanic trade supervisors are going to be needed across the board throughout the supply chain. The electronics and electrical products manufacturing supervisors are going to be needed in the battery materials production, the battery cell manufacturing, and the EV assembly sectors. The supervisors in motor vehicle assembling are going to be needed in the EV assembly space, of course. And then the supply chain tracking and scheduling coordination supervisors, they're going to be needed across the board. Of course, we need the logistics people in order to be able to make sure that the parts get from one place to the other in the right amount of time and at the right time for them to be used in the manufacturing process. We have two more groups to look at. We have the skilled trades. In this particular category, we identified 4 skilled trades, which are going to be in very high demand, critical for the EV battery supply chain. They include the industrial electricians, the heavy-duty equipment mechanics, the construction millwrights and industrial mechanics, and the welders and related machine operators. In the case of the heavy-duty equipment mechanics and the welders and the related machine operators, their focus is in the mining and minerals section for the heavy-duty equipment mechanics. They're going to be the ones who are overseeing that heavy-duty equipment that is going to be needed to actually do the mining. And then the welders and machine operators are needed in the EV assembly space. The other skilled trades are going to be able to find roles in all of the various different sectors if they have a particular interest in that. When we take a look at the laborers themselves, we have a number of different types of laborers. These are individuals who don't necessarily have to have a post-secondary education, but will have to have some on-the-job experience in order to do their role. So we're going to need people who are good at electronics assembly, fabrication, inspection, and testing. We're going to need people in metal fabrication, mineral and metal processing as well, electrical apparatus manufacturing, machine operators and inspectors. We're going to need material handlers across the spectrum. Those are the people who are going to be working in the warehouses to make sure that the materials get from one place to another. And then the motor vehicle assemblers, inspectors, and testers are going to be needed in the EV assembly space. When we take a look at the types of skills that these individuals are going to need in order to be successful at their role, we see a wide variety of different technical skills that are going to be needed for the EV battery supply chain to be successful in Canada. When we take a look at automotive automation and robotics, we're talking about the fact that the manufacturing lines are becoming much more automated, and roboticists are going to be needed as well. We need people specialized in battery science and battery recycling. We need chemical specialists, people specializing in data analytics. Of course, electrical and electronics and electrochemistry are going to be high demand skills, as are manufacturing skills, material science skills, so understanding how materials work, mechanical and mechatronic skills, metallurgy, so the study of actual metals and mining materials, and then the mineral processing skills. On the professional or transferable skills side, we're also going to need some very important skills for these workers to be successful. We're going to need these individuals to be able to do deep critical thinking in order to be able to solve problems when they come up and to develop new solutions to those problems. Collaboration. All of these people are going to be working on teams, not only with people who are doing the same job, but they're going to be working on teams with people who are doing very different jobs as well. So collaboration and teamwork are really important professional skills that are going to be required. We're also going to need problem solving skills, like with the critical thinking skills. Anytime we're developing a new process or putting up a new facility, problem solving is going to be critical. Root cause analysis, that's the skill of identifying when you see a problem, what's really causing that problem. Not just, we don't want to just address the symptom of the problem. We don't want to address what's happening on the surface. We want to figure out deep down what's causing that problem and address that particular process. Lean manufacturing principles, that's the idea that we want to keep our inventories as slim as possible to be as efficient as we can be when it comes to manufacturing. And then, of course, in Canada, we want to have a very strong emphasis in sustainability, and we want those sustainability principles to be an important component of the EV manufacturing staff that we're going to be working with across the board. So let's take a quick dive into some of the new technology in the manufacturing sector that we can expect to see in the EV battery supply chain. We've got 5 different buckets here. Let's start with data analytics and AI. So data analytics and AI can be useful for a couple of different aspects of manufacturing. One aspect is predictive maintenance. If we have AI and data analytics, they can be employed to predict equipment failures and schedule maintenance proactively, which is going to minimize the downtime and optimizes the productivity of the workforce that's working with that equipment. Data analytics and AI can also be used for supply chain optimization. In particular, AI can enhance supply chain management by predicting the demand that's going to be required and optimizing inventory levels and improving overall efficiency. Let's move on to digital twins and simulation. Oh, sorry, let's go back one slide. We're not quite there yet. So digital twins and simulation, in this case, what we're going to see is the ability to model and optimize manufacturing processes, which is going to allow the facilities to do some experimentation and improvement without actually interrupting the production line itself. So the production line can keep going while the engineers are working on ways to improve it. We also have opportunities for remote monitoring and control. And remote operations are a really interesting addition to manufacturing processes. It can improve flexibility and may lead to changes in the actual work environment itself. Virtual reality and augmented reality, or VR and AR, can also be used for training the workers. They can be utilized they can allow the workers to learn and practice their roles in virtual environments before engaging with real world equipment. And then we've also got those robotics and automated vehicles and equipment that I was mentioning before. The advantage of the robotics is that it provides us with precision and consistency in the manufacturing process. Automated systems can handle delicate and intricate tasks with a level of precision that manual labor sometimes has a challenge with. And then I think another great aspect of robotics and automated equipment is worker safety, because automation can reduce the exposure of workers to potentially harmful substances, especially in the battery materials manufacturing process. And it can mitigate the risk of accidents as well. All right. So that summarizes the basic research that we did in order to produce the sector profile on the EV battery supply chain. And we found that if we summarize those events, that research, there are vast opportunities for workers, but there's also a need for a lot of additional training for workers in order to get up to speed to do the work that's required in Canada. A couple of other resources that we produced along with the sector profile that I was just talking about is an interactive tool, a map of career pathways, which is available online on our website. This interactive tool gives you information about a number of different important or critical roles in EV manufacturing, and then also provides an opportunity to see what similar roles or what roles might be similar in terms of skill sets that you could move into if you wanted to. So in this case, we're highlighting industrial engineering technologist as one of the roles that's important. And there are a number of different other roles which you can hover over with your mouse, and you can see what those roles are and how similar they are to the industrial engineering technologist occupation. And then we've also generated what we call competency profiles. A competency profile is like a picture, a description of what an individual needs to do in order to be successful at a particular job. So a competency profile is going to provide an overview of that particular role, what's involved in the role. It's going to talk about the education requirements. It's going to talk a little bit about what sort of background is needed in order to do the on-the-job training. And then it's going to look at 4 buckets of competencies: technical competencies, professional and personal competencies, which are also what we refer to as transferable competencies, regulatory and legislative competencies, so knowledge of regulations and legislation, which is an important component of a lot of environmental jobs, and then specific environmental competencies. So on the screen here, we have a list of the competency profiles that we have available on our website, which identify the specific competencies needed for conservation scientists, electronics technicians, mechanical engineers, manufacturing engineers, robotics technicians, environmental compliance specialists and environmental technicians, recycling coordinators, and so on. If you're interested in more information, please check out our website. Some of these have been fully validated by the people who work in that space. So we're confident that the roles that have been, the competencies that have been identified are fully accepted. In some of the cases, we're still looking for validators. And so if you're in one of these roles, do check out our website, take a look at the competency profile for that role. And if we still need validators, reach out to us and let us know whether we're on the mark with that particular research or whether we need to make some modifications to it.
Awesome, thanks, Jenny. So I'm just going to go back to the first slide, and we're going to click over some questions here. I have some coming in. Perfect. So this question came back a little while ago, but one question here is: will this include sodium-ion batteries, solid-state batteries, cobalt-free chemistry, etc., additional to conventional Leon?
That's a good question. The research we did was based on the current technologies that are being used for EV battery manufacturing. We didn't explore the opportunities for new technology and new innovative types of batteries. So that is an area where we would like to do more research. And it's an emerging sector, but right now those would be falling in our what we would call our clean tech sector, because those are still emerging technologies from the perspective of the EV battery supply chain.
Awesome, thanks, Jenny. Next question here. The better part of the EV battery value is in the downscalability for the reuse once past their prime in vehicles, and then recycling. Is this part of this program?
The recycling and reuse of the batteries is an important component to the battery supply chain sector. We want to look from the beginning to the end of the life and then return that material back to productive use. As I mentioned in the the discussion a little bit earlier, Canada right now has a really fragmented recycling and reuse sector when it comes to battery recycling. And so this is an area where we're going to have to do a lot more investment and exploration of opportunities for that batteries recycling to take place.
Awesome, thanks. Another question here. What is done for those who want to learn and grow within the battery manufacturing? I want to grow in this sector of EV.
Well, I guess the straightforward answer is that a lot of these companies that are making those large investments are going to be looking for workers to train up in order to get those facilities operating. There is some discussion about them bringing in staff from abroad, simply because those foreign workers may have the experience already to get those facilities up and running. The hope, though, is that those facilities are then going to be able to train and develop Canadian staff in order to be able to get that battery recycling or that battery manufacturing up and running. I think the bigger challenge is, there are a lot of different sectors and a lot of different types of roles that we're talking about here. Some individuals might be interested in getting into the mining sector. I know that the Mining Human Resources Council is desperately trying to put out the message that there is a need for individuals in the mining sector. When it comes to individuals in the battery cell manufacturing sector, that's really a new space. We don't really have a well-established training program or upskilling program for workers in that space right now in Canada, so we're still working on that. In terms of the EV assembly, of course, we've got a number of companies that are doing internal combustion engine cars right now in Canada and are switching or going to be moving some of their assembly lines over to EVs, and they will provide training for their workers as well. And then in the recycling and reuse space, again, I think we're talking about a lot of innovative type jobs, people coming up with clever solutions in order to be able to get those materials out of the former products and into productive use again.
Awesome. And the last question I see here is circular supply chains, donut economics, and industrial ecology are much more important than in EV batteries. What skilled jobs are there for this?
Oh, gosh. Uh, I'll be honest, I don't know the answer to that question. I haven't explored that.
Awesome. We'll definitely keep looking around our socials and see if we have something come up on that. Next question here is how much work needs to be done or is being done with post-secondary institutions to do the bulk of this training right now, to get them on site?
Well, there is interest certainly in the post-secondary education sector. One of the other challenges that wasn't mentioned in the research that we did is that often the post-secondary educational institutions take a long time in order to establish new curriculum or new programs. So a university, for example, could take a number of years for a new program or curriculum to go from an initial idea to a fully fledged program that's up and running. Some of the polytechnic institutions are doing some good work in terms of training some of the staff to do the mechanics of EVs. But again, a lot of the infrastructure needed for the post-secondary training is still lacking in Canada at this point.
And then here's the last question that keeps coming in is, do you fear that Canada will be slow to act to improve the supply demands for this EV market growth?
Well, I think there are some challenges that are going to be faced in Canada. We know that there are a lot of minerals available in the Canadian landscape. What we haven't necessarily accounted for is all of the regulatory and legislative hurdles that a mine needs to go through in order to get it up and running. It can often take 5 to 10 years to get a mine up and running from the initial permitting application to the actual operation of the mine. And if we're really urgently in need of some of these materials, we may be having to look abroad in order to find those materials to satisfy the supply chain needs in the interim. Now, there are opportunities for governments to streamline some of those regulations, but those regulations are in place for a variety of reasons, mainly to prevent environmental damage. And so we don't want to necessarily lessen the regulations that are imposed on Canadian mining efforts, but we also don't want to make them obstacles, make those regulations to be hurdles that can't be achieved. Um, Again, another challenge, if we are looking abroad for minerals, there are concerns about the sustainable production of those minerals abroad. And some cases, the minerals are not being produced in a sustainable fashion, either environmentally sustainably or culturally or socially sustainably. And so that is a consideration that we want to take into account as well. The facilities themselves, there have been a few hiccups along the line in terms of companies that are putting forward these investments in the EV battery supply chain. We've had a slowdown globally in the demand for EVs. The growth in EV adoption has not been quite as fast as governments had hoped. And so a lot of companies are starting to pull back on the initial investments that they had made. So far, we don't have word on investments being pulled back in Canada, but there are examples of that happening in Europe. But we do have some EV plants themselves, manufacturing plants for the cars that are not necessarily going to switch from internal combustion engine to EVs as quickly as had been hoped.
Awesome. Thanks for that answer, Jenny. So I think that's it for questions for today. If you have any more questions, please reach out to ECO. Please look at our website at eco.ca, see all the events that we have coming up, as well as webinars. And please follow our socials as well. Keep up to date on everything we're doing. Thanks everyone for joining. I really appreciate it. Thanks, Jenny.
Thank you, Chase. Thank you,
Bye-bye.
everyone.